Long-running operations leave users staring at blank screens, but real-time progress updates can change that. We'll implement a FastMCP client with a custom progress handler that shows percentage completion and status messages, giving users clear feedback during extended tasks. You'll see exactly how to structure the handler and connect it to your client in just a few lines. From FastMCP import client. Async def my progress handler. Progress, float. Total, float none. Message, SDR none. To none. If total is not none. Percentage equals progress/total, 100. Printf progress, percentage, 1f% message or else. Printf progress, message or client equals client. My MCP server, pi. Progress handler equals my progress handler. This demonstrates the callback pattern for asynchronous progress reporting. The handler function acts as an observer, receiving updates from long-running operations without blocking the main execution flow. What makes this distinctive is its non-intrusive design, where progress tracking becomes a separate concern from core business logic. The pattern works through event-driven communication between the server and client. The server emits progress events during execution, while the client subscribes via a handler function that processes these updates independently. This separation enables real-time feedback without tight coupling, as neither component needs awareness of the other's implementation details. This approach solves the common problem of opaque long-running operations in distributed systems. Clients gain visibility into processing status, preventing perceived hangs or timeouts, while servers maintain clean, linear workflows. The trade-off is minimal. You add a simple handler function, but gain user transparency and the ability to implement custom progress visualization. Let's break it down line by line. From FastMCP import client. Imports the client class from FastMCP, the primary interface for connecting to and interacting with MCP servers. This is the entry point for all server operations, including tool registration and progress reporting. Async def my progress handler. This defines an async callback function for progress reporting. FastMCP invokes this during long-running operations, enabling real-time status updates without blocking the main thread. The async pattern ensures it integrates cleanly with FastMCP's event loop. Progress, float. The progress, float parameter tracks the current progress value in absolute units. It represents how much of the operation has completed, whether that's bytes transferred, items processed, or any other measurable unit. This enables precise progress reporting for both bounded and unbounded operations. Total, float none. This type annotation declares total as an optional float, using Python's union type syntax. It enables the progress handler to work in both relative mode with a total and absolute mode without, making the function more flexible for different progress reporting scenarios. Message, SDR none. This parameter accepts an optional string message, enabling progress updates with contextual details. The none type hint explicitly allows omitting messages when only numeric progress matters, preventing unnecessary empty string checks. To none. This return type annotation declares the function returns nothing. It enforces type safety by explicitly stating this is a void callback, preventing accidental return value usage in the progress handler. If total is not none. This checks if total was provided, enabling percentage calculation. Without this guard, Dividing by none would raise a type error when progress reporting lacks a total reference. It's a defensive pattern for optional progress tracking. Percentage equals progress/total, 100. This calculates the completion percentage by dividing current progress by total work, then scaling to 100. Standard progress reporting pattern that converts raw values into user-friendly percentage metrics. Printf progress, percentage, 1f% message or. This formats the progress output with 1 decimal precision while handling optional messages. The OR pattern ensures the message field never breaks the string format, preventing none-related errors when no message exists. Else. This handles the case where no total value exists. When progress tracking uses absolute values instead of percentages, this branch ensures the handler still works by printing the raw progress value. Printf progress, message or. This handles the indeterminate progress case where no total is known. The message or pattern safely defaults to an empty string if no message exists, preventing none-type errors while maintaining clean output. Client equals client. This instantiates the FastMCP client, the main entry point for all server interactions. The client manages the connection lifecycle, handles progress reporting through our callback, and routes tool executions to the server. My MCP server, Pi. This specifies the local MCP server file to connect to. FastMCP uses this path to locate and communicate with your server implementation, enabling tool execution and progress tracking. Progress handler equals my progress handler. This assigns the custom progress handler to the FastMCP client. The handler receives real-time progress updates during long-running operations, enabling user feedback or logging. Without this, progress tracking would be silent. This closing parenthesis terminates the client instantiation, finalizing the configuration with our custom progress handler. Without it, the object creation would be incomplete, causing a syntax error. Progress reporting pattern. FastMCP's progress handler bridges the gap between long-running server operations and client awareness, transforming raw progress data into meaningful user feedback. The total parameter being optional means your handler must gracefully handle both bounded and unbounded progress scenarios. Always design progress handlers to be stateless, as they may be called from multiple concurrent operations.
The progress bar that never reaches 100% still completes the work.